The story begins with a silence so vast it feels almost sentient, a silence that presses against the edges of human imagination until it buckles. Picture yourself floating far beyond Earth, past the familiar scatter of constellations, past the thin shell of meaning we project onto the night sky. The farther you drift, the more your senses fail to keep up. Distances stretch beyond language, beyond metaphor, until even your thoughts feel small, flickering like sparks in a void too immense to care whether they exist. This is the threshold where the human mind begins to falter. This is where the colossal galaxy first reveals itself, not through numbers or diagrams, but through the crushing realization that scale itself can be a form of terror. We are creatures built to understand rooms, roads, mountains, oceans. Our imaginations have grown ambitious over millennia, but even at their most daring, they strain to encompass anything larger than the sphere of a single world. And yet here we stand, peering into a cosmic titan whose dimensions multiply past billions, a structure so vast it breaks the very tools we use to conceptualize distance. You glance at a map of the Milky Way or some artistic rendering of a distant star system, and it looks manageable, flat, tidy, reduced. But remove the comfort of diagrams and place yourself in raw intergalactic space, and suddenly the truth becomes overwhelming. The colossal galaxy stretches outward like a living continent of starlight, a continent so inconceivably large that your mind instinctively tries to shrink it just to protect itself. As your eyes adjust to this cosmic panorama, the first sensation you feel is awe, a kind of trembling recognition that everything you've ever called big was a warm-up for this. Stars gather in luminous rivers, each one burning with unimaginable fury, yet from this distance they look like grains of glowing dust. You try to focus on a single cluster, but it's like trying to count trees while falling past an entire forest. Every point of light is a sun, every sun could host worlds, and every world could carry the ruins of forgotten stories. But the deeper you gaze, the more the galaxy expands, pushing outward in every direction until perspective itself becomes unreliable. It's too much, too wide, too deep. Human intuition shatters somewhere around this moment. And yet, inside this dizzying immensity, something else awakens, a quiet fear. Not the fear of danger, but the fear of insignificance. Humans rarely confront the raw truth of scale. We live inside a fragile narrative where our concerns matter, where our days are meaningful, where the world is small enough to understand. Here that narrative collapses. You begin to sense the crushing height of the cosmic stage on which you play a role so small that even calling it a role feels generous. For the first time, you feel the galaxy not as an object but as an overwhelming presence. A cathedral of matter and light whose sheer magnitude reduces you to a whisper drifting through eternity. Yet this fear carries a strange beauty. It dismantles ego, leaving behind only curiosity, the same primal curiosity that pushed our ancestors to cross oceans, climb mountains, and map the night sky with trembling hands. You feel that instinct again now, stirring beneath the weight of your insignificance. If something so colossal exists, then what else is waiting in the dark? What mysteries stretch across those spiraling arms? How many civilizations tried, and failed, to interpret this infinite maze of stars? In this way, awe becomes fuel, igniting a desire to know more, to step closer, even if the very act of understanding might break the limits of the human mind. As you drift nearer, the galaxy reshapes itself from a distant swirl into a sprawling world. Patterns emerge, clusters, filaments, dark lanes. The luminous core pulses faintly like a heart beating behind veils of dust. The outer arms twist like vast rivers frozen in motion. You understand now that the galaxy isn't a static image, it's alive with movement. Stars orbit with slow, inevitable grace. Clouds collapse. Dust flows. Light stretches across gulfs of emptiness that have existed for billions of years. Everything moves in silence, but the silence feels orchestrated, purposeful, like a cosmic symphony playing far beyond the reach of sound. This is where imagination begins to stretch again, trying to adapt, trying to build a framework large enough to hold what the eyes can barely process. But even now, even with this fuller view, you sense there are limits. Your mind keeps attempting to impose structure, shapes, borders, patterns, yet each attempt collapses when confronted with the sheer immensity. It's as though the galaxy is quietly telling you, you can see me but you cannot grasp me. Not fully. Not ever. And in that realization lies an unusual kind of humility, the kind that comes only from confronting something so far beyond your scale that it redefines the word large. Slowly you begin to notice something else, a tension between what you think you understand and what remains hidden. Every glowing region hints at storms of creation. Every dark gap hints at secrets buried in shadow. There is a sense of depth layered beneath the visible, like the galaxy is not just a physical structure, but a narrative unfolding across billions of years. A narrative filled with events too vast and too slow for human senses to detect. Collisions that take millions of years. Births that unfold over epochs. Patterns that require cosmic patience to see. And beneath it all, a question emerges, persistent and unsettling. If the galaxy is this immense, what forces shaped it? What ancient fires forged its first stars? And what unimaginable scale lies beyond even this? You feel a pull, not physical but intellectual, a need to follow these questions into the heart of the galaxy, to peel back its layers and uncover the truths hidden within its swirling arms. But as you prepare to venture deeper, one more realization brushes against your thoughts. If this colossal galaxy is so vast that imagination falters at its edges, then what does that say about the universe beyond it? If one galaxy can dwarf the human mind, how do we begin to comprehend the millions, perhaps billions, stretching out in the darkness? The question hangs there, unresolved, as if the cosmos itself is waiting for you to take the next step. The deeper you drift toward this colossal galaxy, the more the concept of measurement begins to crumble. Numbers, those familiar companions of human understanding, suddenly feel primitive, almost childish. Kilometers, miles, even light years become nothing more than fragile metaphors trying to wrap themselves around something that refuses to be contained. At first, you try to lean on scale models in your mind, little comparisons that once made the cosmos feel accessible. If the Earth were a marble, if the sun were a coin, if the galaxy were a city, but every analogy collapses before it is even complete. There is no object, no experience, no stretch of land or sea in all of human existence that can represent the immensity now unfolding before you. You stare into the spiraling arms stretching outward like colossal ribbons of fire and shadow. Each glowing thread contains more stars than every grain of sand on Earth's beaches combined, and this is merely a fragment of the whole. Human language gives you words like trillion, quadrillion, uncountable, but none of them truly register. They hang in your mind as hollow symbols, their meaning fading the moment you attempt to connect them to the structures before you. It is not that the galaxy is too large to describe, it is that the human brain was never designed to process this magnitude in the first place. Yet, despite this cognitive failure, something extraordinary happens. Your imagination does not shut down, it stretches. It tries desperately to keep up. You watch as clusters bloom like frozen fireworks, each explosion containing a million suns. Dark lanes curve across the spiral arms like vast scars, each one a continent of dust thick enough to hide entire stellar nurseries. These regions glow faintly from within, as if something ancient is stirring behind a curtain of cosmic smoke. Every piece of the galaxy hints at a structure so detailed and so layered that even attempting to map it becomes a challenge of patience more than intelligence. The more you examine it, the more the galaxy begins to feel like a world made of worlds. A labyrinth of interconnected realms, each with its own history, its own storms, its own mysteries. You imagine standing inside one of these arms, looking out across a canyon of stars so vast that the opposite side would appear as a faint blur of light. If a civilization lived there, their night sky would be a tapestry of burning suns, overlapping like embers in a cosmic forge. But from where you hover now, outside the whirlwind, all of it blends into an enormous system that moves with an elegance so precise it feels choreographed. A strange thought enters your mind: how can something this massive be so organized? Gravity, the unseen sculptor, whispers its influence across every curve, every cluster, every hidden void. You see stars orbiting with perfect obedience, taking hundreds of millions of years to complete a single circuit. In the human world, a century is considered a lifetime. Here it is a heartbeat. 1,000 years, an entire civilization's rise and fall, is nothing more than a flicker of cosmic time. The galaxy operates on scales that make human history feel like a brief candle lit in the vastness of night. But even gravity has its limits. It can bind stars, shape orbits, and sculpt spirals, yet the true architecture of the galaxy is far stranger. There are regions where stars gather in tight swarms, others where they drift alone through haunting emptiness. Ribbons of dust twist like ink dropped into invisible currents. Streams of gas stretch for thousands of light years, pulled and shredded by forces you can barely imagine. The galaxy is not a simple spiral. It is a complex, living structure, shifting and reshaping itself over billions of years. It feels almost alive, not in the biological sense but in the way a storm or ocean is alive, responding to forces too large to see but too real to deny. Numbers try to give form to this chaos. Scientists speak of mass, luminosity, rotation curves. They assign values based on observation, building elegant models that dance across computer screens. But standing here, immersed in the raw reality, those numbers seem like faint outlines of a beast too large to draw in full. Even the measurements themselves betray an uncomfortable truth. No one really knows the exact size of this galaxy. Every new discovery expands its boundaries, adding more stars, more clusters, more hidden structures. It is as though the galaxy is playing a quiet game of deception, revealing just enough to invite further curiosity while hiding its full nature behind veils of complexity. You begin to feel the emotional weight of this vastness, not fear, not insignificance, but a trembling appreciation for the universe's scale. It becomes clear that understanding this galaxy is not about memorizing statistics. It is about confronting the limits of human imagination. Every star you see represents a place you will never visit, a story you will never witness. Every cloud of dust hides processes too slow for human perception, unfolding over epochs that stretch beyond the concept of lifetimes. The galaxy does not rush. It does not hurry. It exists in a state of eternal patience, sculpting itself silently across billions of years. There is a beauty in this patience, a beauty that feels almost philosophical. The galaxy teaches you something without words: perspective. Human worries shrink in comparison to a structure that has existed since long before your species evolved and will continue long after it is gone. Yet instead of making you feel small, the realization fills you with a strange, uplifting awe. To witness something so immense, so ancient, so impossibly complex, this is a reminder that being small does not mean being meaningless. If anything, it means you are part of a universe grander than your mind can hold, and there is a kind of grace in that. But beneath this grace lies a lingering mystery. If numbers fail to capture the true scale of the galaxy, what else might we be misunderstanding? What details lie hidden behind the glow of starlight, concealed in regions too distant or too faint for observation? What forces shape this cosmic titan, and what secrets still lie buried in the dark spaces between its arms? The galaxy seems to invite these questions, offering just enough clarity to inspire wonder before fading once again into a blur of immeasurable depth. You drift farther into its radiant expanse, aware now that every answer will only lead to deeper mysteries. Beyond the limits of numbers, beyond the reach of imagination, something waits, something vast, ancient, and still largely unseen. And as you cross this threshold, a final thought stirs quietly in your mind. If one galaxy can defy understanding so completely, what unimaginable scale lies beyond it in the darkness? As you leave the comforting glow of familiar stars behind, the vastness of the galaxy becomes an oppressive silence, stretching for light years in every direction. It is not a silence that can be measured by the absence of sound, for in space sound barely exists. It is a silence that presses on the mind, heavy with emptiness, immense in scale, and yet saturated with untold potential. Every blink of your vision captures distant points of light, but the vast distances between them are filled with nothingness, an emptiness so complete that it almost feels like a presence. It is in these voids that the mind begins to strain, reaching for connections, patterns, anything familiar to anchor itself against the magnitude of the unknown. And yet, the void remains indifferent, infinite, silent. The concept of distance becomes surreal. Light, the fastest traveler in the universe, takes years to cross even a fraction of the space before you. One star is separated from another by tens of thousands of light years, each light year a staggering 9 trillion kilometers. Numbers, once comforting, now fail again. You attempt to visualize this emptiness, flying past a star and realizing that even at unimaginable speeds, it would take tens of thousands of years to reach its neighbor. The scale is beyond comprehension. It is no longer a galaxy as a collection of stars, but a cathedral of distances, an architecture of nothingness where every luminous point is a beacon in a sea of dark. Despite the emptiness, the galaxy is never still. In this silence, subtle movements play out across unfathomable expanses. Stars orbit the galactic center in a slow, stately dance that takes hundreds of millions of years to complete a single cycle. Vast clouds of gas drift languidly, collapsing over eons to give birth to new stars, while remnants of supernovae, ghostly shells of energy, float like the echoes of ancient explosions. Even the darkness itself is not truly empty. It carries gravitational tugs, invisible currents, and unseen structures that shape the flow of matter. The silence is layered, rich with invisible activity, like a symphony composed of frequencies beyond human perception. As your awareness deepens, fear mixes with awe. The vast, silent distances evoke the same trembling you might feel when standing at the edge of a cliff overlooking a chasm that stretches endlessly. You feel tiny, fragile, and infinitely remote from everything that might have been familiar. And yet, this very vulnerability evokes fascination. The galaxy scale creates an emotional tension between helplessness and wonder, a duality that pulls the mind into an almost meditative state. It is a place where logic and imagination collide, where the human brain must simultaneously confront emptiness and the possibility of untold richness. Moving closer to the spiral arms, you notice patterns emerging amid the void. Stellar clusters shine like small islands in a boundless ocean, their light piercing the darkness with remarkable clarity. But each cluster is separated by expanses so vast that they might as well be isolated worlds. The eye searches for continuity, for some sense of cohesion, yet the galaxy maintains a deliberate distance, refusing to be fully grasped at once. This contrast between the light of stars and the profound darkness between them becomes a recurring theme, a visual representation of tension and mystery that the mind cannot fully resolve. The emptiness itself begins to tell a story. Rogue planets drift alone, far from any star, silently wandering in regions where light has not touched in millions of years. Ancient clouds of dust, relics of long-dead stars, form ghostly veils that obscure the light beyond. In these spaces, time feels stretched, almost fluid, as though the passage of years is imperceptible against the immensity of space. You begin to realize that the galaxy's silence is not passive, it is alive in its own way. It holds secrets of creation, destruction, and transformation that unfold at a pace humans cannot directly perceive. Yet, within this silence, flashes of narrative emerge. Pulsars blink with precise regularity, emitting rhythmic bursts of energy that hint at phenomena too extreme to witness in person. Neutron stars spin at incredible velocities, remnants of violent deaths that occurred millions of years ago. Supernova remnants expand into emptiness, sending ripples of matter across vast distances. The galaxy's silence is not empty, it is punctuated by these events, brief and brilliant interruptions in an otherwise still expanse. Each event carries a story, of creation, destruction, and the passage of cosmic time, that adds depth to the otherwise daunting emptiness. As you journey further, the realization sinks in. This light-year-spanning silence is both the galaxy's frame and its canvas. It shapes the perception of everything within it, emphasizing the brilliance of stars, the density of clusters, and the isolation of worlds. Contrast becomes more than a visual element, it becomes an emotional experience. The brighter the star, the darker the space around it seems by comparison. The more massive the cluster, the more pronounced the emptiness becomes. This interplay creates a tension that is both beautiful and disorienting, inviting the mind to dwell in a paradox of proximity and distance. The human mind, trained to seek patterns and connections, struggles here. Every attempt to grasp the entirety of this silent expanse reveals the futility of such an endeavor. And yet, paradoxically, this very futility sparks a deeper curiosity. Questions rise unbidden. What unseen forces shape this vast emptiness? What ancient events left their mark on regions where light will not reach for millennia? Could there be worlds, life, or phenomena hidden within these stretches of apparent nothingness, waiting to be discovered? The silence teases, offering glimpses of truth without revealing the whole, keeping your mind suspended in a state of urgent curiosity. The emotional weight of this realization is profound. The galaxy's silence is both humbling and exhilarating. It evokes a sense of temporal and spatial vertigo, a feeling that human existence is fleeting and insignificant on the grand scale. Yet it also kindles a spark of wonder, a desire to explore, to imagine, and to push against the boundaries of perception. Every light year of emptiness becomes a canvas for the imagination, a space where awe and fear coexist, and where questions are as powerful as answers. As you drift on, the galaxy's silent expanse seems to stretch infinitely, each passing moment revealing new gaps, new clusters, new contrasts between light and dark. The mind struggles, falters, and adapts, finding beauty in the incomprehensible. And just when you feel the limits of your perception are reached, another luminous cluster or distant nebula appears, a reminder that there is always more to see, more to question, more to understand. In this endless expanse of light years and silence, curiosity becomes the only guide, and wonder becomes the only constant. The silence, at last, becomes almost a companion, an ever-present force that shapes your experience and perception. It teaches patience, humility, and the thrill of confronting the unknown. And as you prepare to move closer to the galaxy's more turbulent regions, you carry with you the profound awareness that in this vastness, every question you ask is dwarfed by the magnitude of the answers still waiting, hidden in the darkness between the stars. Long before the first flicker of intelligent thought ever emerged on Earth, this colossal galaxy began its existence in a chaotic, incandescent maelstrom of gas, dust, and gravity. Imagine the early universe, barely a few billion years old, still cooling from the cataclysmic birth of existence itself. In this primal expanse, clouds of hydrogen and helium swirled like colossal eddies, pulled and stretched by gravity's invisible hands. Within these clouds, turbulence raged. Particles collided, spun, and coalesced, creating the seeds of something far larger than any human mind could imagine. The galaxy's birth was not a gentle process but a violent, almost mythic event, a cosmic storm that combined both destruction and creation in equal measure. You try to picture it: immense clouds stretching thousands of light years, collapsing under their own weight, igniting into the first generations of stars. Explosions marked their births, sending shockwaves through neighboring clouds, triggering yet more star formation in a chain reaction that seemed almost deliberate. It is a ballet of chaos and order, a paradox where destruction becomes a necessary ingredient for creation. Nebulae glowed with raw energy, their luminescent colors painting the void with shades of red, blue, and gold, as though the universe itself were attempting to create a masterpiece on a canvas of emptiness. Each burst of light was not just an event, it was the birth of a possibility, a chance for worlds, for matter, and perhaps, eventually, for life. Gravity, the silent architect, worked tirelessly across eons. Clumps of matter attracted more matter, forming the scaffolding of the galaxy. Some regions became dense, forming tightly bound clusters of stars, while others remained diffuse, creating the vast arms that would eventually spiral outward like colossal celestial ribbons. The interplay of collapse and expansion, of force and counterforce, was not instantaneous but stretched over millions of years. In this patient, relentless shaping, the galaxy took on its first recognizable form, a fledgling titan, still raw, unrefined, and pulsing with potential. Amid this turbulence, stars lived and died in spectacular fashion. Massive suns burned fast and bright, only to explode violently as supernovae, scattering heavier elements across the surrounding medium. These elements, carbon, oxygen, iron, and beyond, were the building blocks of planets, moons, and eventually life. Without this violent gestation, the galaxy could not have developed complexity. You can almost feel the energy of those ancient detonations, each one a heartbeat in the galaxy's early life, each one shaping the environment for generations of stars to come. The cycle of life and death on a stellar scale mirrors, in an exaggerated and epic way, the patterns found in the most intricate natural systems on Earth, yet magnified across dimensions that human intuition struggles to grasp. The formation of the galactic core adds another layer of drama. Amid the chaos, a supermassive black hole took shape at the center, its gravitational pull anchoring the emerging structure. It is a paradoxical creator, a void so dense that not even light can escape, yet exerting a force so immense that it shapes the motion of billions of stars. The galaxy's first dance began around this enigmatic heart, with matter swirling in vast spirals, collapsing inward only to be ejected again in energetic bursts. The black hole is both a destructive and generative force, a reminder that creation and annihilation are inseparably linked in the cosmos. In contemplating it, you realize that even emptiness has power, and that in this emptiness lies the framework for everything that follows. From the chaos of the early universe, order slowly emerged. Arms spiraled outward, sweeping clouds of dust and stars into elegant patterns. Clusters condensed, leaving immense voids between them that accentuated the galaxy's enormity. It was a system of breathtaking complexity, where every region contained unique processes unfolding at unimaginable scales. Each star was a miniature sun in its own right, each nebula a theater of ongoing creation. And yet, from a distance, the galaxy would have appeared as a coherent, almost purposeful design, a balance of light and darkness, order and chaos, expansion and collapse. The story of this birth is not only about scale but also about timing. The galaxy's formation did not follow a strict schedule. It was the result of countless interactions, collisions, and chance alignments of matter over billions of years. Some regions ignited early, forming stars that would become anchors for clusters. Others lagged, remaining clouds of dust waiting for the right conditions to collapse. The galaxy's shape, structure, and composition are the product of both inevitability and randomness, a delicate dance between determinism and chance on a cosmic canvas. Every spiral arm, every dense core, every scattered star bears witness to this intricate choreography. And yet, despite the apparent order, mystery abounds. The earliest events are largely obscured, hidden in the distant past and veiled by layers of subsequent creation. The galaxy keeps its secrets well. You can infer the general sequence, but the details, exact timings, precise conditions, unknown forces, remain beyond the reach of direct observation. This tension between what can be known and what must be imagined adds an emotional layer to your understanding. You are both an observer and a storyteller, piecing together fragments to form a narrative, yet always aware that the full story is larger than any single mind can hold. The birth of the galaxy is also a story of contrast, creation amidst destruction, chaos giving rise to order, emptiness filled with potential. It evokes an emotional response that is both humbling and inspiring. You sense the patience required for such a system to emerge, the countless failures that preceded its successes, and the relentless power of forces that shape matter and energy over incomprehensible time scales. There is terror in imagining such raw power, yet beauty in the harmony it eventually produces. As you reflect on this ancient genesis, you are struck by its implications. If such complexity, structure, and elegance can emerge from chaos on this scale, what does it say about the universe as a whole? And more personally, what does it say about the human capacity for understanding, for wonder, for imagination? In witnessing the galaxy's birth, you confront both the limits of comprehension and the exhilaration of approaching the unknown. It is a paradox of scale and perception. The more immense the galaxy, the more profound the sense of curiosity and awe. The cosmic storm that forged this colossal galaxy was not a single event, but a continuous process, still echoing in every spiral arm, in every cluster, in every speck of dust. Its birth was violent yet deliberate, chaotic yet patterned. And in the contemplation of this primal act, you begin to sense a truth that resonates beyond numbers and light years. Creation on a cosmic scale is an act of both patience and fury, a testament to the universe's capacity for wonder. The galaxy, born in fire and turbulence, is a living monument to the paradox of cosmic genesis, destruction and creation, silence and eruption, chaos and order, woven together in a structure so vast that human imagination falters at its edges, yet cannot help but reach toward it with awe. At the very center of this colossal galaxy lies a force so enigmatic, so terrifying, that it challenges every instinct of perception: the supermassive black hole. Unlike anything found on Earth, it is both invisible and omnipotent, a singularity where matter and light converge, and yet, paradoxically, its influence radiates outward across tens of thousands of light years. Imagine a point so dense that the known laws of physics warp around it, where time stretches and twists, where gravity exerts a pull impossible to resist. It is the heart of darkness, a core that commands the galaxy's very structure, dictating the orbits of billions of stars while remaining hidden, silent, and unknowable. You approach it not with fear of collision, but with a sense of reverent awe. The black hole exerts a gravitational grip that anchors the galactic arms, orchestrating the movements of countless celestial bodies in a slow, eternal dance. Stars trace elliptical paths like obedient dancers around an unseen maestro, their motions governed by an entity that cannot be seen, touched, or measured in conventional terms. The galaxy's heart pulses silently, a quiet authority dictating rhythm across hundreds of millions of years. You realize that the more you study it, the more it defies understanding. Its mass is incomprehensible, its influence infinite, yet its presence is almost ghostly, revealed only through the consequences of its gravity. The imagery here is both terrifying and mesmerizing. Gas and dust spiral inward, forming accretion disks that glow with energies billions of times more intense than the sun. Magnetic fields twist and snap, generating jets of radiation that shoot across interstellar distances like cosmic lances. These jets pierce the galactic plane, carrying matter away at near-light speeds, a violent counterpoint to the black hole's invisible pull. The core becomes a paradoxical theater of creation and destruction. While it consumes anything that dares approach, it also triggers bursts of star formation in nearby regions, recycling material into the galaxy in a cycle of death and rebirth. Emotion floods the mind as you contemplate this singularity. There is fear in imagining the scale of its power, the ultimate inevitability of being drawn toward its event horizon, where the universe itself bends and stretches. Yet there is wonder too, an appreciation for the sheer audacity of existence. A black hole of this magnitude is not just an astronomical object, it is a testament to the extremes of nature, a reminder that the universe can contain both unimaginable void and staggering brilliance. It embodies contrast, annihilation versus creation, emptiness versus radiance, mystery versus observable consequence. The philosophical implications are equally profound. Standing before the concept of the supermassive black hole, you are forced to confront human limitations. Our understanding of physics begins to crumble in its presence. Time dilates unpredictably near its edge. Light itself can be trapped, stretching across epochs before escaping, or never escaping at all. What does it mean to exist in a universe where a single point can wield such authority over billions of stars? How does one reconcile the notion of being a mere observer of such overwhelming power? And yet, in that tension, there is a kind of awe that transcends fear, a compelling reminder that the cosmos is not bound by human scale or expectation. As your awareness deepens, you begin to visualize the dynamic interactions around the core. Stars that wander too close are torn apart by tidal forces, shredded into streams of gas that spiral inward, feeding the insatiable void. Occasionally, a massive star explodes in a supernova near the black hole, its remnants caught in a gravitational ballet that lasts millennia. Entire clouds of gas are compressed and heated, igniting waves of star formation that ripple outward. The black hole is a paradoxical agent. It destroys to create, consumes to enable, annihilates to renew. Every phenomenon in its vicinity is both terrifying and beautiful, a narrative of cosmic extremes unfolding in silence. The center of the galaxy is also a place of light and shadow. Dense clouds of dust obscure direct observation, creating dark regions that conceal violent interactions from the distant eye. These shadows deepen the sense of mystery, suggesting processes and events beyond immediate comprehension. Observers must rely on indirect clues: shifts in star velocities, the glow of heated gas, the patterns of radiation emitted in jets. Each signal offers a glimpse into the otherwise invisible mechanics of the black hole, a tantalizing puzzle that challenges both imagination and intellect. Emotionally, the human mind struggles here. One feels simultaneously infinitesimal and privileged, tiny in the face of overwhelming gravity, yet capable of observing, imagining, and conceptualizing what no other species on Earth could perceive. It is a confrontation with ultimate power and ultimate mystery, a silent dialogue between human curiosity and cosmic enormity. The black hole stands as the galaxy's sentinel, its darkness a mirror reflecting the limits of perception, and yet, paradoxically, a beacon illuminating the extremes of existence. Even at the edge of comprehension, the black hole's influence is undeniable. It shapes the rhythm of the galaxy, holding stars in orbit, shaping the spiraling arms, and dictating the fate of matter that ventures too close. The dynamic balance it creates gives the galaxy form and stability, despite its violent tendencies. The more you study it, the more apparent the duality becomes. The heart of darkness is also the source of life, the agent of both destruction and creation, the axis around which billions of lives and untold phenomena revolve. As your gaze lingers, a final haunting question emerges. What truly lies beyond the event horizon? Human physics falters, imagination strains, and even the most advanced instruments offer only glimpses of possibilities. The singularity is a place where known reality dissolves, where matter and time lose their familiar meanings, and where even light can no longer escape. It is the ultimate boundary of understanding, a reminder that for all our knowledge, the universe contains secrets far beyond human reach. The black hole is not merely an astronomical feature. It is a philosophical crucible, forcing reflection on scale, mortality, and the limits of comprehension. In its silent, consuming presence, you feel the tension between curiosity and fear, between knowledge and the unknown. You understand that this darkness is both literal and metaphorical. It is the void at the center of the galaxy, and also the threshold of imagination, a boundary that challenges humans to expand their minds while acknowledging the vastness that will always remain beyond. And as you finally step back, gazing at the surrounding spiral arms swirling in obedience to this invisible monarch, you feel a strange exhilaration. The galaxy revolves, lives, and breathes around a heart that embodies extremes, contrasts, and mysteries. It is terrifying, yes, but it is also profoundly beautiful, a testament to the universe's capacity for scale, complexity, and paradox. The heart of darkness is not only a force of destruction, it is the source of structure, of continuity, of the eternal rhythm that sustains the colossal galaxy. In contemplating it, you understand that true wonder lies not just in seeing, but in grappling with what cannot be fully seen, in facing a presence so immense that human imagination falters, yet refuses to look away. As you venture deeper into the sprawling arms of this colossal galaxy, you encounter celestial bodies that defy every expectation, every law of nature as you have known it. These are not the comforting, familiar stars of our night sky, the sun-like points of light whose warmth has guided human life for millennia. These stars are titans, cosmic beasts burning with unimaginable intensity, so massive and volatile that they stretch the boundaries of physics itself. They illuminate the void not with gentle radiance, but with a raw, almost aggressive brilliance, their very existence a challenge to human comprehension. You feel both awe and fear as you witness them, knowing that each could outshine our sun 1,000,000 times over, each a furnace where elements are forged in violent crucibles, each a testament to the extremes of cosmic power. The most immediate sensation is scale. Some of these stars dwarf entire star systems, their diameters extending billions of kilometers. You try to picture it, a sphere so vast that if it replaced the Sun at the center of our solar system, its surface would extend past the orbit of Saturn or even Jupiter. Their gravity is crushing. Anything nearby is caught in a relentless orbit or torn apart by tidal forces. These stars live fast, burn hotter, and die younger than their smaller siblings, their lifespans fleeting by cosmic standards, yet they leave legacies imprinted across light years of space. Each one is a drama in motion, a narrative of birth, life, and inevitable cataclysm that unfolds over millions of years, yet in a blink of cosmic time it is gone, an ember extinguished, leaving only echoes in the surrounding clouds of gas and dust. The colors alone are staggering. Some blaze with deep blue-white intensity, so hot that even light itself seems to quiver in their presence. Others shimmer with fiery reds and oranges, the signature of cooler, but no less massive, giants burning through their fuel in a blaze of turbulent energy. Nebulae around these stars glow in response, forming halos and filaments that writhe and shimmer, like celestial auroras frozen in motion. The contrasts between light and darkness are striking. The brilliance of these stellar titans against the void around them creates an emotional tension, a constant reminder that beauty and danger often coexist in the cosmos. You notice that these stars are not solitary, they interact in ways that challenge imagination. Binary and even multiple star systems form, where massive stars orbit one another in gravitational duets. Their mutual influence can stretch or distort their shapes, pulling matter into streams that spiral like ribbons before being ejected into space. These interactions are violent and unpredictable, producing bursts of radiation, gravitational waves, and occasionally triggering supernovae that scatter enriched material across vast distances. Even in these extreme conditions, the galaxy maintains a form of rhythm, a balance between chaotic force and overarching order. Observing this, you feel both fear and fascination. Fear at the destructive power, fascination at the intricate dance choreographed by physics on scales incomprehensible to human experience. The death of these titanic stars is a spectacle beyond description. Supernovae erupt with cataclysmic force, releasing more energy in a few seconds than our Sun will emit in its entire lifespan. Entire regions of the galaxy are illuminated in sudden, blinding brilliance, as shockwaves propagate across surrounding interstellar clouds, triggering the birth of new stars. In some instances, the core collapses into a black hole, a miniature echo of the supermassive one anchoring the galaxy's center, adding another layer to the cycle of creation and destruction. It is a relentless feedback loop, a cosmic narrative in which each ending seeds a beginning, where life and death coexist in a continuum of staggering scale. And yet, amid this chaos there is order. The positions, motions, and interactions of these stars are dictated by the invisible architecture of the galaxy. Gravity, magnetic fields, and angular momentum shape their trajectories, creating patterns that, while unpredictable on a human timescale, form a kind of visual and mathematical harmony over millions of years. There is artistry in the violence and elegance in the forces at play. You realize that understanding these stars is not merely about measuring mass or luminosity. It is about grasping the interplay of extremes, heat and cold, gravity and inertia, life and annihilation, that defines the very character of the galaxy. Philosophically, these stellar titans evoke questions about human perception and limitation. How can a mind trained on the modest scales of Earth comprehend objects that live and die across dimensions of magnitude far exceeding our experience? How can imagination stretch to accommodate energies and forces that dwarf every terrestrial comparison? The stars demand humility, forcing recognition that even in the age of advanced science, the universe contains realities beyond immediate understanding, phenomena that challenge assumptions, and extremes that test the elasticity of human cognition. As you continue to explore, subtle patterns emerge. Regions densely populated with these massive stars form nurseries of extraordinary activity, where radiation pressures sculpt the surrounding gas into intricate filaments, pillars, and bubbles. Some regions resemble celestial cities, glowing with a frenetic energy that suggests life and movement even in their lifelessness. Others are sparsely populated, dark, and brooding, hinting at the voids where gravity has yet to ignite new creation. The contrast between these zones creates a rhythm across the galaxy, a symphony of extremes in which massive stars play both solo and ensemble roles in a performance that unfolds over millions of years. The presence of these titans also affects the smaller, less dramatic stars. Their intense radiation can strip atmospheres from nearby planets, sculpt nebulae, and even influence the formation of stellar clusters. They are both creators and destroyers, architects and executioners. Their influence extends far beyond their immediate vicinity, a reminder that the galaxy is not a collection of isolated phenomena but an interconnected web of cause and effect on scales difficult to comprehend. Emotionally, witnessing these stars is both exhilarating and humbling. You are confronted with forces so vast, processes so powerful, that human existence seems fleeting, almost inconsequential in comparison. Yet, at the same time, there is inspiration in recognizing that these extremes exist, that life can emerge, and that the universe is capable of both beauty and terror on scales unimaginable. The mind is forced to expand, to grapple with contradictions, and to embrace a mixture of wonder, fear, and curiosity that is uniquely human. Even as you leave these regions behind, the image of these colossal stars lingers, a reminder that the galaxy is not a static structure but a dynamic, ever-evolving entity. Each massive star is a character in a vast narrative, a node in an intricate network of creation, destruction, and transformation. Their brilliance and violence punctuate the silent expanses, providing both light and drama, and reinforcing the overarching truth of the galaxy. It is a realm of extremes, a place where imagination strains against the sheer magnitude of reality, and where every corner of space holds both mystery and revelation. The journey through these stars leaves an indelible impression. You sense that the galaxy's story is written not just in planets or black holes, but in the lives of these titanic suns, in the brilliance and violence they bring to their surroundings. Each one challenges logic, stretches comprehension, and ignites a visceral sense of awe. And as you move on to explore further regions of this vast structure, you carry with you the memory of these celestial giants. Their radiance, their fury, their paradoxical roles as both destroyers and creators, and the profound reminder that the universe is a place where extremes are not only possible but necessary, shaping the cosmos in ways that human minds can barely imagine. As you drift farther from the luminous arms of the galaxy, the environment transforms into a realm of quiet isolation, where light grows faint and the void stretches unbroken for thousands of light years. Here, in the shadow of the colossal stars and nebulae, lie the hidden planets, worlds that escape immediate notice, drifting silently through space like cosmic secrets. Some are tethered to stars, orbiting in vast ellipses that take centuries or even millennia to complete. Others are rogue planets, cast adrift by violent gravitational interactions, wandering the dark expanses alone, unseen and unilluminated, carrying only the faint warmth of residual heat from their formation. The sheer variety of these hidden worlds defies expectation. Frozen wastelands, molten infernos, gas giants larger than Jupiter, and rocky planets scarred by millennia of collisions. Each world holds its own story, its own microcosm, yet most remain utterly unreachable, existing in profound solitude within a galaxy that dwarfs comprehension. The first sensation is the contrast between light and shadow. Near the bright stars, planets shimmer faintly, their atmospheres catching scattered light, painting themselves in subtle colors that hint at oceans, clouds, or storms. But in the deeper void, rogue planets drift like ghosts, invisible to all but the most sensitive instruments. Some may harbor subsurface oceans warmed by internal heat, while others are barren, frozen spheres that have wandered in darkness for billions of years. The sense of isolation here is palpable. It is a loneliness that is both literal and emotional, a solitude magnified by the enormity of the surrounding galaxy. The mind struggles to comprehend a planet untethered, traveling endlessly through a void that seems to stretch to infinity, a lone voyager in a silent sea of darkness. The environmental extremes on these planets are staggering. Some orbit too close to their stars, their surfaces blistering under relentless radiation, their atmospheres torn away by stellar winds. Others reside in frigid outer regions, where even hydrogen begins to freeze, forming icy landscapes illuminated only by distant, fading starlight. Rogue planets add another layer of mystery. Worlds adrift without a central sun, potentially warmed only by residual heat from formation or internal radioactive decay. You imagine what life, if any, might endure in such isolation. Perhaps microbial organisms exist in subterranean oceans, hidden from the harsh cold of space. perhaps nothing survives at all. The uncertainty itself becomes part of the fascination, a tension between hope and emptiness, between the possible and the unknowable. The rogue planets in particular evoke a sense of awe and unease. Cast out from their parent stars, they wander silently, eternal travelers in an indifferent universe. Some may carry moons, forming miniature systems that drift as self-contained islands in darkness. Others may harbor thick atmospheres that retain heat, creating hidden pockets of warmth in an otherwise frozen exile. The possibility of life, even in microscopic form, becomes a tantalizing thought, a spark of mystery that lights up the otherwise cold emptiness. And yet, these worlds exist in isolation beyond imagining, far removed from any civilization or observation. They are the ultimate embodiment of cosmic solitude, reminders of both the galaxy's richness and its indifference. Planetary formation in these regions is a slow, deliberate process. Dust clouds collapse under gravity, forming planetesimals that collide and merge over millions of years. Sometimes the formation is violent, with collisions that reshape entire surfaces, creating mountains, valleys, and cratered wastelands. Other times, it is gradual, a patient accumulation of material that eventually coalesces into a stable world. Even in these remote areas, the forces of physics shape the planets with precision and elegance. Gravity, angular momentum, and the subtle interplay of pressure and radiation carve each world uniquely, a reminder that even in isolation, the universe follows patterns of order amidst apparent chaos. Some of these planets exist in precarious orbits, near the edges of gravitational systems, where perturbations from passing stars or neighboring clusters can eject them into interstellar space. Others form in binary or multiple star systems, their trajectories a complex ballet around two or more suns. These arrangements create environments of extreme variability, tidal locking, fluctuating radiation, and complex climatic patterns that could render the surface uninhabitable, or in rare cases uniquely suited to life. The contrast between stability and chaos, between isolation and connection, imbue these worlds with an almost narrative quality, as though each planet is a character in a story written in gravity, time, and light. The visual landscapes are as diverse as the physical processes that shape them. Some planets are veiled in thick, swirling clouds of ammonia or methane, their skies lit by strange, filtered light from distant suns. Others are jagged, rocky spheres marked by impact craters and deep canyons, landscapes frozen in time. Gas giants shimmer with bands of color, storms raging for centuries across their vast surfaces, while icy moons orbit silently, casting long shadows across frozen seas. The contrast between light and shadow, heat and cold, movement and stillness, create a cinematic tapestry that evokes wonder and unease in equal measure. Emotionally, encountering these hidden worlds evokes a sense of both curiosity and humility. You realize the galaxy is not just a collection of stars, but an intricate network of planets, each with its own potential and mystery. Some may hold the ingredients for life, others are barren testaments to the indifferent forces of physics. Every orbit, every atmosphere, every surface feature tells a story of creation and survival, of forces far beyond human comprehension. And yet, despite this complexity, these worlds remain mostly hidden, invisible to the casual observer, waiting silently for discovery. As you contemplate these planets, a philosophical tension emerges. They are isolated, yet connected to the galaxy as a whole through gravity, radiation, and time. They are fragile yet resilient, formed over eons and capable of enduring in extreme conditions. They are both known and unknowable, tangible in their physical presence yet mysterious in their potential for life or change. This duality mirrors the larger tension of the galaxy itself, a structure of incomprehensible scale that can be studied, measured, and observed, yet always retains elements beyond reach, beyond imagination. The hidden planets also highlight the interplay between chance and necessity. Some were formed in predictable regions near dense star clusters. Others were expelled into the void by gravitational interactions. Some have stable conditions that might allow life. Others are violently inhospitable. The galaxy's architecture, while governed by physical laws, also produces randomness and surprise, ensuring that every exploration reveals something unexpected. In this way, the hidden planets are not merely passive objects. They are participants in the galaxy's ongoing narrative, symbols of its complexity and unpredictability. Even as you move past them, the impression lingers. The hidden planets serve as reminders that much of the galaxy's drama unfolds in silence, away from the brilliant light of stars. They are quiet witnesses to cosmic history, repositories of potential and mystery, drifting through darkness yet contributing to the galaxy's intricate tapestry. Each planet, whether solitary or in a distant system, is a testament to the scale, diversity, and complexity of the cosmos, evoking a mix of awe, curiosity, and existential reflection. As you leave these worlds behind, one final thought resonates. In the vast expanse of the galaxy, there are realms of solitude and mystery that even the most powerful telescopes may never fully reveal. These hidden planets, drifting in light years of silence, challenge imagination and inspire wonder. They embody the duality of the cosmos, both indifferent and magnificent, silent yet full of story, and serve as a reminder that even in the darkest, most remote regions, the galaxy's secrets continue to wait patiently for minds daring enough to seek them. As you move deeper into the colossal galaxy, the landscape transforms once again, this time into flowing rivers of cosmic dust that weave through the stars like celestial veins. These are not rivers of water or liquid, but immense streams of gas and microscopic particles, drifting across space in patterns that suggest both motion and purpose. Nebulae glow softly in hues of red, blue, and gold, illuminated by the stars within and beyond them, while dark filaments of dust obscure parts of the galaxy like shadows stretching across a sunlit field. The first impression is one of awe, a sense that the galaxy is alive, breathing, shifting imperceptibly but relentlessly over eons. Each stream seems to pulse with unseen energy, a current in a vast, silent ocean that flows through the interstellar void. The texture of these rivers is mesmerizing. You can imagine clouds of dust colliding and intertwining, forming dense knots that eventually collapse into new stars. Light scatters across tiny grains, creating halos and wisps that shimmer as though the galaxy itself were painting in slow motion. In some regions, the dust is thick and almost tangible, casting shadows across neighboring clouds, while in others it is sparse, a faint mist that hints at the presence of unseen matter. These contrasts, the heavy and the light, the bright and the shadowed, create a rhythm across the galactic landscape, a visual symphony that evokes both wonder and tension. You feel as if you are drifting along one of these rivers, carried by invisible currents through a realm of silent, intricate complexity. Movement in these cosmic rivers is slow yet relentless. Over millions of years, clouds of dust spiral into dense knots, collapsing under gravity's persistent pull. Stars ignite within these nurseries, sending radiation that shapes the surrounding material, carving cavities and pillars that stretch for light years. Shockwaves from supernovae ripple through the clouds, compressing some regions while dispersing others. The galaxy is alive in its subtle motions, and the dust rivers are its arteries circulating energy, matter, and potential throughout the system. You sense the immense timescales at play, processes so slow that human perception cannot grasp them fully, yet so persistent that they shape the galaxy's architecture in fundamental ways. The interplay of light and shadow is particularly striking. Dense dust lanes block starlight, creating areas of deep darkness that contrast sharply with the glowing regions nearby. The galaxy seems to play with perception, revealing parts of its structure while concealing others, teasing the mind with glimpses of what lies hidden. These dark regions are not empty, they are pregnant with possibility. Within their obscurity, new stars may be forming, planets taking shape, or perhaps phenomena yet unknown to human science. The tension between what is seen and what is hidden evokes a sense of mystery, a feeling that the galaxy holds secrets that will remain just out of reach, challenging imagination and observation alike. As you follow the paths of these dust rivers, you notice subtle variations in density and composition. Some clouds are rich in carbon and oxygen, ingredients essential for planetary formation and life as we know it. Others are dominated by hydrogen, helium, or more exotic elements, remnants of ancient stars that lived and died long before the solar system existed. These differences influence the evolution of each region, dictating the types of stars that will emerge and the potential for planets to form. It is a cosmic alchemy, a slow, deliberate process of transformation that unfolds over millions and billions of years, yet feels almost choreographed in its elegance. The rivers of dust also convey a sense of scale and interconnection. You realize that no star, planet, or nebula exists in isolation. Each is linked through these flowing streams, their motions subtly influenced by gravity, pressure, and radiation from distant sources. Even the void between the dust is not truly empty, it carries the gravitational echoes of distant masses, bending the paths of clouds and shaping the long-term architecture of the galaxy. This interconnectedness evokes a philosophical reflection. The galaxy is not merely a collection of objects, but a dynamic, interwoven system, where even the smallest particles play a role in the grand narrative of cosmic evolution. Emotionally, the rivers of dust inspire both awe and introspection. There is beauty in their forms, complexity in their motions, and a profound sense of patience in their creation. You sense the enormity of the forces at work, the delicate balance between creation and destruction, order and chaos. The dust streams remind you that the galaxy is not static. It is a living system, constantly reshaping itself, recycling matter, and fostering the conditions for new phenomena. There is a quiet poetry in this realization. The galaxy breathes in dust and gas, in light and shadow, in creation and collapse. The mystery deepens as you consider what may lie hidden within these clouds. Darker regions could conceal protostars, planetary embryos, or even structures yet undiscovered, phenomena that challenge the limits of observation and imagination. The light that reaches you is only part of the story. Much remains veiled, waiting to be revealed by patient exploration or new technologies. This sense of hidden potential adds an emotional tension, a feeling of anticipation that drives curiosity and wonder. You are compelled to imagine the unseen, to ponder the possibilities encoded in the swirling patterns of dust and light. Moreover, these cosmic rivers demonstrate the cyclical nature of galactic evolution. Stars born from dust clouds will live, die, and return material to the interstellar medium, enriching future generations of stars and planets. Supernovae, stellar winds, and gravitational interactions all feed back into the system, ensuring that no dust remains inert for long. The galaxy is thus a perpetual workshop of creation, and the rivers of dust are the veins through which its lifeblood flows. Observing this cycle evokes a sense of temporal depth, a recognition that the galaxy operates on scales far beyond human comprehension, yet with a coherence that speaks to the fundamental laws of physics. The visual experience of these dust rivers is cinematic. Columns of dark matter rise against glowing nebulae, arcs of light stretch across voids, and faint wisps twist like smoke in an eternal slow-motion dance. The contrast between dark and light, motion and stillness, chaos and order, create a sensory experience that is both overwhelming and exhilarating. You feel as if you are navigating a river not of water but of time and possibility, carried along by forces both familiar and alien, witnessing the quiet majesty of processes that shape entire galaxies. As you continue to drift among these rivers, a lingering thought emerges. The galaxy is not merely composed of stars and planets, but of the subtle interplay of matter, energy, and time. The dust, the clouds, the flows, all contribute to the narrative of cosmic evolution, forming both stage and script for the drama that unfolds on scales unimaginable to human minds. In contemplating these rivers, you realize that the universe is as much about the spaces between as the objects themselves, and that silence, motion, and contrast are as vital to understanding the galaxy as its brilliant lights and colossal masses. By the time you move past these flowing rivers, the impression they leave is indelible. They are symbols of creation, carriers of mystery, and vessels of awe. The galaxy breathes through them, recycles through them, and reveals its complexity through their forms. You understand that to study the stars alone is to see only the surface. The rivers of cosmic dust hold the deeper, quieter narrative, the hidden story of a galaxy that is alive, patient, and infinitely intricate, waiting for minds capable of both observation and imagination to follow its endless currents. As you journey deeper into the heart of this colossal galaxy, you begin to witness phenomena of staggering violence. Worlds, stars, and entire clusters colliding in a slow-motion dance of destruction and creation. Unlike the serene spirals of starlight that dominate the outskirts, these regions pulse with chaotic energy, where gravitational forces tug relentlessly, drawing celestial bodies into fatal embraces. Collisions on this scale are not instantaneous. They unfold over thousands or millions of years, yet the consequences are monumental. Planets are shattered, stars ignite prematurely, and clouds of gas and dust are compressed and expelled, seeding the galaxy with the raw ingredients for new creation. The enormity of these interactions forces the mind to stretch beyond intuition. Entire solar systems are reduced to rubble, only to be reassembled by forces beyond comprehension. The first encounter with such a collision evokes both awe and terror. Imagine two massive star clusters, each containing millions of stars, slowly approaching each other under the pull of gravity. At first, they appear as distant, shimmering clouds, their paths predictable and elegant. But as they draw nearer, tidal forces begin to distort their shapes. Stars are torn from their orbits, forming elongated streams that stretch across light years, while gas clouds compress and ignite, giving birth to new stars in bursts of brilliant light. You feel the tension of these events, destruction and creation intertwined, chaos giving rise to order, violence producing beauty. Every moment of this cosmic interaction is a spectacle, a narrative written in motion, energy, and light. Planetary collisions are equally dramatic, though invisible from afar. Rogue planets, or those in unstable orbits around massive stars, can be flung into one another, their crusts pulverized, molten cores exposed, debris scattered across the void. Some may merge into larger bodies, forming entirely new worlds. Others are torn apart entirely, leaving only fragments to drift indefinitely, occasionally forming rings around surviving planets or stars. The scale is incomprehensible. The energy released in these impacts dwarfs anything humanity could imagine, equivalent to billions of nuclear detonations occurring simultaneously over centuries. And yet, in the aftermath, there is creation. Material recombines, forming new planets, moons, and even asteroid fields, continuing the cycle of cosmic evolution. Stars themselves are not immune to collision. In dense clusters, gravitational interactions can send massive stars careening into one another, triggering supernovae far earlier than their natural lifespans. These explosions release shockwaves that compress surrounding clouds of gas, sparking additional star formation in a cascading sequence. You can almost feel the energy reverberating through space, a silent symphony of destruction and renewal. The contrast is mesmerizing. Immense violence giving rise to breathtaking beauty, annihilation birthing possibility, a perpetual cycle of death and rebirth writ on a galactic scale. The collision of entire galaxies is another layer of cosmic drama. Though rare, these events occur over hundreds of millions of years, as two massive systems draw closer under gravity's inexorable pull. Stars rarely collide directly due to the vast distances between them, yet their gravitational interactions warp and twist the galactic structure. Spiral arms stretch and merge, gas clouds compress and ignite, and new generations of stars are born in the turbulence. Massive black holes at the centers may spiral toward one another, unleashing gravitational waves that ripple across the universe. The spectacle is grander than any planetary collision, an epic scale of chaos that reshapes the very architecture of the cosmos. It is both terrifying and beautiful, a demonstration of forces far beyond human comprehension. Amid these colossal events, contrast becomes the guiding principle of observation. Light and darkness, creation and destruction, chaos and order, all exist simultaneously. Some regions blaze with the birth of new stars, while others are shadowed by collapsing gas and swirling debris. Some planets survive relatively intact, while others are reduced to dust. This interplay of extremes evokes profound emotional responses: fear of annihilation, awe at the forces at play, wonder at the intricate choreography of matter across vast distances. The galaxy is both indifferent and purposeful, a realm where violence is a necessary precursor to creation. Time itself takes on a new dimension in these colliding worlds. What seems instantaneous in human perception is, on cosmic scales, an epic of motion and transformation. Millions of years pass in the blink of a galactic eye, during which stars are born, die, and recycle their material, planets are destroyed and reborn, and light travels across immense distances to reach observers at the right moment. This temporal perspective challenges the mind, forcing an understanding of processes that far exceed human lifespans. You feel simultaneously distant and intimately connected, aware that these collisions are part of a rhythm that has existed for billions of years and will continue long after humanity has vanished. The visual landscape of these collisions is breathtakingly cinematic. Streams of stars arc across the void like molten ribbons, clouds of gas glow in vibrant hues of red, green, and blue, and shockwaves propagate through space, compressing and shaping material with silent force. The contrasts between violence and elegance create a tension that grips the imagination, a constant reminder that the universe operates on scales and principles far beyond everyday experience. You sense a narrative unfolding in these interactions, a story without words but rich with drama, tension, and consequence. Collisions also reveal the interconnectedness of the galaxy. No event exists in isolation. A planetary collision may trigger star formation in a nearby cloud. A supernova may compress a distant nebula, creating conditions for future stars. Galactic mergers can reshape entire regions, altering orbits and redistributing matter. The galaxy is a network of cause and effect, where every action reverberates across light years. Observing this interconnectedness evokes both intellectual and emotional responses. Understanding the mechanics inspires awe, while the realization of scale and complexity inspires humility. Emotionally, witnessing these colliding worlds is a blend of exhilaration and existential reflection. You confront the raw power of the universe, the forces that shape existence itself, and the impermanence of seemingly solid structures. Yet in this awareness there is inspiration. The galaxy's chaos is not meaningless. It is a mechanism for creation, a crucible in which matter is constantly reshaped, transformed, and given new potential. Destruction is not final but a precursor to new beginnings, a reminder that the universe's story is one of perpetual evolution. Even as you drift past these tumultuous regions, the memory of colliding worlds lingers. They are both violent and beautiful, terrifying and inspiring, a vivid demonstration of the galaxy's extremes. You sense that understanding the cosmos requires more than knowledge of physics. It demands an emotional engagement with scale, time, and consequence. The narrative of colliding worlds is a microcosm of the galaxy itself, a dynamic system of forces, interactions, and contrasts, where every collision is both an ending and a beginning, a chapter in a story that stretches across billions of years and untold light-years of space. And so, as you continue your journey through the galaxy, you carry with you the awareness that destruction and creation are inseparable. The colliding worlds are not anomalies, they are essential components of the galaxy's life, a testament to the balance between chaos and order. They embody contrast, drama, and scale in ways that challenge human comprehension, yet they also inspire a profound sense of wonder, a recognition that even in the most violent processes, the universe is both beautiful and purposeful, a realm where extremes coexist and the story of existence unfolds on a canvas far larger than the imagination can contain. As you venture further into the spiral arms of this colossal galaxy, you encounter vast nebulae, cosmic clouds of gas and dust that glow and swirl in colors both vivid and alien. These nebulae are regions of intense activity, where the raw materials of the universe gather, collide, and ignite in processes that span millions of years. Some glow with fiery reds and oranges, heated by the radiation of nearby massive stars, while others shimmer in icy blues and greens, cooler and more quiescent, yet no less vital to the galaxy's ongoing evolution. The sheer scale of these structures is staggering. Some stretch hundreds of light-years across, their intricate filaments twisting and curving in patterns that suggest both turbulence and purpose. It is as if the galaxy itself has painted across the void, creating masterpieces that exist on scales incomprehensible to the human mind. The sensory impact of these nebulae is immediate. You imagine drifting along their edges, passing through clouds thick with hydrogen, helium, and traces of heavier elements forged in the hearts of previous generations of stars. Light scatters and refracts, creating luminous veils that glow faintly in shadowed regions and blaze brilliantly near areas of star formation. The contrasts are striking. Fiery eruptions of newborn stars punctuate cooler, darker areas, while jets of gas burst outward in ribbons that twist and coil across the void. Each filament and cavity tells a story of creation and destruction, of energy released and matter sculpted over millions of years. Observing these processes evokes a mixture of awe and humility, as you realize the galaxy is a living, breathing entity operating on scales far beyond ordinary comprehension. Nebulae are the crucibles of star formation. Within their dense regions, gravity pulls matter together, collapsing clouds of gas into compact cores that will eventually ignite as stars. In some areas, this process is violent. Shockwaves from nearby supernovae or colliding gas streams compress the material, triggering bursts of star formation in clusters. These newborn stars ignite with brilliance, their light ionizing surrounding gas and creating luminous bubbles that expand outward. The contrast between the violent ignition of new stars and the surrounding calm regions of dust and cold gas creates a dramatic visual and emotional effect, emphasizing the delicate balance between chaos and order that governs the galaxy. Some nebulae appear almost sculpted, their shapes shaped by unseen forces over millennia. Dark lanes of dust carve shadows through glowing gas, forming pillars, cavities, and twisting arches that evoke the imagery of cathedral interiors or surreal landscapes. Jets of material from young stars pierce the clouds, creating corkscrew patterns that extend for light years. These structures are not static. They shift imperceptibly as gas flows, collapses, and ignites. Observing a nebula over cosmic time is to witness a story written in light and matter, a tale of turbulence, patience, and transformation that plays out on a stage far larger than human experience can grasp. The interplay of fire and ice within these nebulae adds layers of contrast and mystery. Regions heated by massive stars blaze with energy, emitting ultraviolet radiation that excites surrounding gases, causing them to glow in brilliant reds and oranges. Elsewhere, cooler areas shimmer in blues and greens, composed of hydrogen, oxygen, and other elements that remain unlit until disturbed. This juxtaposition creates tension and balance, light and dark, heat and cold, creation and dormancy. It mirrors the duality inherent in the galaxy itself, a reminder that extremes coexist and that the processes of the cosmos operate across a spectrum of intensity, often simultaneously. Beyond their visual spectacle, nebulae play a critical role in the chemical evolution of the galaxy. They are reservoirs of elements forged in previous generations of stars, including carbon, nitrogen, oxygen, and heavier metals. As new stars form, they incorporate these elements, continuing a cycle of matter recycling that enriches the galaxy over billions of years. Some nebulae even contain complex molecules, the precursors to organic chemistry, hinting at the potential for life in distant yet to be discovered planetary systems. Observing this, you recognize that nebulae are not merely clouds of gas and dust. They are laboratories, workshops of creation, where the galaxy manufactures the building blocks for worlds and perhaps even life itself. The motion within these nebulae is subtle but relentless. Gas flows along pressure gradients, turbulence creates vortices and filaments, and gravity continuously pulls matter toward forming stars. Over millions of years, entire regions are reshaped, compressed, or dispersed. You sense a rhythm in this motion, a slow pulse that orchestrates the dance of matter across the galaxy. Each disturbance, whether a stellar wind, a supernova shockwave, or gravitational tidal forces, adds complexity to the evolving structure, ensuring that no two regions are ever identical. The nebulae are dynamic, ever-changing sculptures, frozen in motion yet alive with processes too slow for human eyes to perceive directly. Emotionally, the nebulae evoke a complex response. There is beauty in their colors and forms, wonder in the processes occurring within them, and humility in the recognition of their scale. At the same time, there is tension. Within these clouds lie both creation and destruction, birth and death, calm and turbulence. The contrast is striking and mirrors the larger narrative of the galaxy. You are reminded that life, matter, and energy are intertwined, that the forces shaping the galaxy are neither benevolent nor malevolent, but impartial in their grandeur and precision. As you move through these regions, you also encounter the consequences of previous generations of stars. Supernova remnants glow faintly, their material expanding into surrounding gas clouds, enriching the nebulae with heavier elements and triggering new waves of star formation. Stellar winds carve cavities, creating dramatic structures that seem almost intentional in their design. The nebulae are thus both archives and laboratories, repositories of the galaxy's past and sites of ongoing creation. Observing them evokes a sense of temporal depth, a reminder that the galaxy is a continuous narrative, where every event leaves traces that shape the future. The visual spectacle is cinematic. Columns of glowing gas twist against dark voids, jets of matter spiral outward from newly ignited stars, and waves of radiation create shimmering halos that stretch across vast distances. Light interacts with dust, scattering and refracting to produce subtle gradients, veils, and shadows. The contrasts between movement and stillness, between luminous and dark regions, create a sense of drama and scale that transcends words. You feel as if you are navigating a living artwork, a gallery where each nebula tells a chapter of the galaxy's story through form, color, and motion. Finally, the nebulae underscore the interconnectedness of the galaxy. They are not isolated phenomena but part of a vast network of matter, energy, and gravitational influence. Each star formed within a nebula will go on to interact with its surroundings, shaping planets, clusters, and even neighboring nebulae. Shockwaves, radiation, and stellar winds propagate outward, influencing regions hundreds or thousands of light-years away. The galaxy is an ecosystem on a cosmic scale, and the nebulae are its fertile grounds, nurturing the conditions for ongoing evolution and transformation. In leaving these regions, you carry with you a sense of awe and reflection. The nebulae of fire and ice are more than visual spectacles. They are engines of creation, archives of the past, and laboratories for the future. They embody contrasts, heat and cold, birth and destruction, light and darkness, that define the galaxy's narrative. In contemplating their forms, motions, and roles, you gain a deeper understanding of the colossal forces at play, the patience and violence inherent in cosmic evolution, and the staggering scale of a universe where beauty and terror coexist across unimaginable distances and timescales. As you travel deeper into the colossal galaxy, a hidden structure begins to reveal itself. An invisible web of magnetic fields threading through space, shaping the movement of gas, dust, stars, and entire star clusters. This magnetic web is not visible to the naked eye, yet its influence is profound, guiding the evolution of the galaxy in subtle but undeniable ways. Imagine a vast network of forces stretching across hundreds of thousands of light-years, bending charged particles, steering interstellar winds, and regulating the collapse of gas clouds into stars. These fields are ancient, generated during the galaxy's earliest formation and continuously amplified and twisted by the motion of matter. They are the unseen skeleton of the galaxy, a framework that provides cohesion, channels energy, and connects distant regions in a silent, intricate conversation. At first, the concept of a magnetic web challenges perception. Space appears empty, a vacuum stretching endlessly, yet it is permeated with these invisible lines of force. Charged particles spiral along them, cosmic rays travel vast distances guided by their paths, and clouds of plasma respond to their presence with subtle motion. In regions of star formation, the fields thread through dense clouds of gas, resisting collapse in some areas while funneling material into others. The result is a delicate balance. Too little magnetic influence and gas clouds collapse chaotically, too much and star formation is inhibited. It is a system of control and feedback operating silently, a cosmic regulator that human imagination can scarcely visualize. The magnetic web is dynamic. Galactic rotation twists the fields into spirals that mirror the arms of the galaxy, while turbulence from supernovae, stellar winds, and colliding clouds creates localized distortions, knots, and arcs. These interactions generate feedback loops that shape the behavior of matter over millions of years. In some regions, fields converge to form filaments, guiding gas and dust into long, slender structures that will eventually birth clusters of stars. In other regions, the fields repel material, carving cavities and voids in the interstellar medium. The interplay of motion and magnetism creates a rhythm across the galaxy, a silent symphony of forces that structures the chaos of matter into patterns both elegant and functional. Visualizing the magnetic web is a challenge, yet its presence can be inferred through the motion and alignment of gas and dust. Polarized light from distant stars reveals the orientation of magnetic lines, while the alignment of dust grains and the behavior of cosmic rays map the invisible currents. In some areas, magnetic tension creates arches and loops that extend for thousands of light-years, tracing elegant curves through the void. These structures are both beautiful and functional. They channel energy, stabilize clouds against premature collapse, and create pathways for matter to flow across the galaxy. Observing them evokes a sense of silent order, a realization that the galaxy is not only composed of visible matter but also shaped by unseen, pervasive forces. The influence of the magnetic web extends beyond star formation. Magnetic fields regulate the flow of cosmic rays, which in turn heat and ionize interstellar gas, affecting chemistry and dynamics. They guide the jets of active galactic nuclei, shaping the distribution of energy emitted from supermassive black holes. Even the spiral arms themselves owe part of their structure to the interplay of gravity and magnetism, as fields help organize the motion of stars and gas into coherent patterns. The galaxy is not simply a collection of luminous objects. It is a dynamic ecosystem with magnetic fields acting as both conduits and regulators, linking processes across vast distances. Emotionally, the magnetic web inspires a quiet awe. It is invisible yet omnipresent, guiding and shaping the galaxy without fanfare or spectacle. It challenges perception, revealing that much of what governs the universe lies beyond direct observation, requiring inference, imagination, and careful study. The subtlety of its influence contrasts with the visible violence of supernovae or colliding worlds, yet its impact is no less profound. There is a lesson in humility here. The galaxy's grand narrative is written not only in light and mass, but in invisible threads that humans can sense only indirectly. The web also underscores the interconnectedness of the galaxy. Regions separated by thousands of light-years respond to one another through magnetic and gravitational interactions. Gas expelled by one cluster may flow along magnetic lines to feed star formation elsewhere. Cosmic rays accelerated in one sector traverse the galaxy along these paths, influencing chemistry and heating far from their origin. The galaxy is a single unified system, a network of matter, energy, and invisible forces that communicate across unimaginable distances. Observing this interconnectedness evokes both intellectual wonder and emotional reflection, emphasizing that the cosmos is far more than a collection of isolated phenomena. The dynamic nature of the magnetic web introduces a sense of tension and contrast. In some regions, magnetic fields restrain collapse, delaying star formation and creating dark, shadowed voids. In others, they funnel material with precision, triggering bursts of creation that light up nebulae in brilliant hues. This balance between suppression and promotion mirrors the duality inherent in the galaxy itself. Extremes coexist, forces act in opposition and cooperation, and the result is a system that is both chaotic and orderly. The contrast between what is seen and unseen, violent and subtle, fast and slow, creates a narrative that engages the mind and imagination simultaneously. The Webb also plays a role in the life cycle of stars and galaxies. Magnetic fields channel matter into accretion disks around forming stars, regulate angular momentum, and influence the evolution of planetary systems. In the vicinity of black holes, they shape jets and outflows, redistributing energy across vast distances. Even galactic mergers are affected as tangled fields twist, compress, and realign, mediating the transfer of matter and energy. The magnetic web is thus a hidden architect, designing, regulating, and sustaining the galaxy across eons. Emotionally, there is a quiet majesty in this realization. Unlike the explosive drama of supernovae or colliding worlds, the magnetic web operates silently, invisibly, yet with pervasive authority. It is a reminder that the galaxy's story is written not only in visible phenomena but also in the subtle, unseen forces that govern the movement of matter and energy. There is poetry in this invisibility. The galaxy is alive in ways that human senses can scarcely perceive, orchestrating events across unimaginable distances with a precision that belies its silent presence. The magnetic web also evokes philosophical reflection. It challenges human assumptions about perception, control, and causality. The forces that shape entire regions are imperceptible, yet fundamental. Matter responds not only to gravity but to currents of magnetism, and the behavior of the galaxy cannot be understood by observing stars alone. This duality, between the observable and the hidden, the violent and the subtle, the immediate and the slow, echoes larger truths about the universe and our place within it. Humans are observers, interpreters, and storytellers, yet much of reality exists beyond immediate perception, waiting to be inferred and imagined. As you move past these regions, the impression of the magnetic web remains. It is a hidden scaffold, a silent regulator, a conduit of energy and matter that ties the galaxy together. It demonstrates that complexity in the cosmos is layered. Visible light, mass, and energy are only part of the story, while invisible forces create structure, guide evolution, and maintain coherence. The magnetic web is both subtle and powerful, quiet yet pervasive, a reminder that the universe operates on scales and with mechanisms that challenge comprehension, inviting awe, reflection, and imagination. By the time you leave the magnetic web behind, you understand its significance. It is the hidden backbone of the galaxy, connecting stars, clouds, and nebulae, guiding processes both violent and gentle, shaping the evolution of matter over millions of years. Its silent influence complements the visible drama of supernovae, colliding worlds, and glowing nebulae, reminding you that the galaxy is a network of interconnected forces, seen and unseen, subtle and extreme, all operating in concert to create a dynamic, living cosmos. The magnetic web is the quiet conductor of this symphony, invisible yet indispensable, a testament to the depth, complexity, and subtle beauty of the universe. As you continue your journey through the colossal galaxy, you begin to sense a hidden framework underlying the visible spectacle of stars, nebulae, and dust clouds, an intricate, invisible network of magnetic fields stretching across the galaxy. This magnetic web is subtle yet omnipresent, guiding the motion of charged particles, shaping the behavior of gas and plasma, and influencing the very formation of stars and planets. Unlike gravity, which acts on mass indiscriminately, magnetic forces interact specifically with ionized matter, weaving an invisible tapestry that governs the flows and currents of the interstellar medium. You begin to realize that the galaxy is not merely a collection of luminous bodies in empty space, but a complex, interconnected system where unseen forces sculpt and sustain its architecture on colossal scales. The magnetic web is ancient, originating from the galaxy's earliest formation and continuously reinforced by the motion of matter over billions of years. Galactic rotation twists the fields into sprawling spirals, echoing the shape of the arms themselves, while turbulence from supernovae, stellar winds, and colliding clouds stretches and contorts them into knots, loops, and filaments. These invisible threads are dynamic, constantly interacting with matter to redistribute energy, regulate star formation, and shape the evolution of gas clouds. In essence, the magnetic web acts as both guide and governor. It channels matter into star-forming regions, prevents premature collapse in others, and subtly influences the trajectories of cosmic rays traveling across thousands of light-years. The Webb is the silent choreographer of galactic dynamics, operating without fanfare yet with profound consequence. Observing the magnetic web is a challenge, for it cannot be seen directly. Its presence is inferred through the behavior of matter and light. Dust grains align along field lines, polarizing starlight in subtle ways that reveal the orientation of magnetic forces. Gas clouds bend, twist, and flow along invisible currents. Cosmic rays, high-energy particles accelerated by distant events, follow the paths dictated by these fields, traveling along arcs invisible to the naked eye. In some regions, the tension of the magnetic field becomes so intense that it shapes entire clouds, forming elongated filaments that stretch across dozens of light-years, guiding the formation of clusters of new stars. In others, it suppresses collapse, creating voids and dark regions that seem deceptively still yet contain untold potential. The galaxy is alive with motion, yet much of it is orchestrated by forces that remain invisible to direct observation. The influence of the magnetic web extends beyond star formation. It regulates the flow of cosmic rays, which in turn ionize and heat the interstellar medium, affecting chemical reactions and the distribution of matter. Magnetic fields help shape the jets of active galactic nuclei, directing streams of matter and energy from supermassive black holes across tens of thousands of light-years. They influence the formation of spiral arms, interacting with gravity to organize stars and gas into coherent patterns. Even the collisions and mergers of clusters are guided, in part, by magnetic fields that twist and redistribute matter during the tumultuous process. The galaxy's visible drama, the explosions, collisions, and glowing nebulae, is inseparable from this invisible structure. Emotionally, the magnetic web evokes a quiet, almost meditative awe. Unlike the violent spectacle of colliding stars or the intense brilliance of nebulae, the web is subtle, pervasive, and enduring. It is the galaxy's invisible skeleton, shaping outcomes without the immediacy of flash or motion. There is a sense of humility in recognizing that so much of what governs the cosmos is beyond direct perception, operating silently yet indispensably. The magnetic web challenges human intuition, reminding observers that the universe is far more intricate than visible light alone can reveal. It is a force that demands both scientific reasoning and imaginative insight to appreciate fully. The web also emphasizes the interconnectedness of the galaxy. Gas expelled by one star may flow along magnetic field lines to fuel the birth of another generation of stars elsewhere. Cosmic rays accelerated by supernovae travel along these invisible highways, influencing regions far from their origin. Entire regions of the galaxy, separated by tens of thousands of light-years, respond to each other through the interactions of matter and magnetism. Observing this interconnectedness creates a profound sense of scale and complexity. The galaxy is not a random assembly of objects but a system in which forces operate across immense distances to produce coherence, structure, and continuity. The contrast inherent in the magnetic web is striking. In some regions, it restrains motion, holding gas clouds in suspense, delaying the birth of stars and creating quiet, shadowed voids. In other areas, it channels material with precision, focusing flows that trigger bursts of star formation and luminous nebulae. This interplay between suppression and facilitation mirrors the larger dualities of the galaxy itself: chaos and order, light and darkness, destruction and creation. The magnetic web is a constant reminder that the universe is a realm of extremes and contrasts, where subtle forces can have as much impact as explosive events. Magnetic fields also govern the life cycle of stars and planetary systems. They influence the collapse of protostellar clouds, regulate angular momentum in accretion disks, and even affect the formation of planetary orbits. Around black holes, magnetic forces shape jets that shoot across interstellar space, distributing matter and energy far beyond the galactic core. These fields are the silent architects of structure, subtly orchestrating interactions that span millions of years and thousands of light-years. Without them, the galaxy would be a far more chaotic and less organized place, a system of stars and gas lacking the coherence we observe. Philosophically, the magnetic web challenges perceptions of reality. It reveals that much of what is fundamental to the universe operates beyond direct human senses, demanding indirect observation, inference, and imagination. Forces that guide entire galaxies are invisible yet undeniable, shaping the cosmos with subtle precision. There is poetry in this invisibility. The galaxy is a living, breathing system in which the most significant influences are unseen, a reminder that complexity often lies hidden, waiting for minds capable of perception and understanding to uncover it. The visual metaphor of the magnetic web is as striking as its function. Though unseen, its effects are apparent in the twisting filaments of dust and gas, in the alignment of stars, and in the flow of energy across the galaxy. It is as if the galaxy is threaded with silent currents, invisible highways along which matter travels, interacts, and transforms. The interplay between the visible and invisible, the dramatic and the subtle, creates a narrative richness that extends beyond mere observation. It is a story of cohesion and tension, of silent governance over chaotic material, and of forces operating on scales that defy imagination. Finally, as you leave the regions dominated by the magnetic web, the awareness of its influence lingers. It is the hidden backbone of the galaxy, connecting stars, nebulae, and dust clouds across immense distances. It orchestrates the dance of matter, channels energy, and maintains structural coherence, all while remaining imperceptible to the casual observer. In contemplating it, you understand that the galaxy is not simply a collection of objects in space but a living system, a network of seen and unseen forces, of extremes and subtleties, all working in concert to shape the story of existence across billions of years. The magnetic web is a testament to the depth, complexity, and hidden beauty of the universe. It is subtle yet powerful, silent yet pervasive, and in its quiet authority, it defines the structure, evolution, and rhythm of the galaxy. By recognizing its presence, you gain a deeper appreciation of the cosmos, understanding that the visible is only part of the story and that the invisible threads of magnetism are as vital to the narrative of the galaxy as the stars, nebulae, and planets they silently bind together. As you approach the central regions of this colossal galaxy, a new force dominates the landscape: the black holes, silent sentinels lurking at the very heart of cosmic architecture. These are not ordinary black holes, but supermassive ones, millions to billions of times the mass of our Sun, whose gravity is so intense that even light cannot escape their grasp. From a distance, they are invisible, yet their presence is undeniable. Stars orbit them in precise, almost choreographed patterns, gas and dust swirl into accretion disks that blaze with intense radiation, and gravitational forces warp the space around them in ways that defy ordinary understanding. These black holes are the architects of the galaxy's center, controlling motion, energy, and even the evolution of nearby stars and planets. The immediate sensation is one of profound awe and fear. Imagine being in a region where gravity is no longer a gentle tug but a relentless, omnipresent force that bends the very fabric of space and time. Matter spirals inward at unimaginable speeds, heating to millions of degrees and emitting powerful X-rays and gamma rays that illuminate the surrounding darkness. Nearby stars are trapped in tight orbits, their paths shaped and distorted by the black hole's immense gravitational influence. Even light itself curves around the edges, creating gravitational lensing that distorts the appearance of everything behind it. Observing this phenomenon evokes a visceral sense of scale and danger. These regions are both beautiful and lethal, places where normal rules of physics are stretched to their extreme limits. Accretion disks around supermassive black holes are particularly striking. They are immense, glowing structures of gas and dust spiraling inward in a brilliant, almost hypnotic dance. Friction and gravitational forces heat the material to extraordinary temperatures, producing radiation that can outshine entire galaxies. Jets of charged particles often shoot outward from the poles at near-light speed, extending thousands of light-years into space. These jets are both terrifying and mesmerizing, piercing the darkness with columns of energy that influence star formation and matter distribution far from the black hole itself. The contrast between the destructive pull inward and the energetic expulsion outward creates a dynamic tension, a visual and physical reminder of the extremes operating at the galaxy's core. Time itself behaves strangely near these black holes. Due to gravitational time dilation, events near the event horizon appear to slow down relative to an outside observer. In a sense, the very passage of time is altered, a reminder that these objects are not just massive but fundamentally alter the rules of reality around them. Stars, gas, and even light follow trajectories dictated not merely by mass but by the warping of spacetime itself. The galaxy's center becomes a theater of extreme physics, a place where intuition fails and human imagination is stretched to its limits. You sense that here at the core, the universe reveals its power and mystery in a form both elegant and terrifying. The black hole's influence extends far beyond its immediate vicinity. Its gravity organizes the orbits of stars in the galactic bulge, maintaining a structural coherence across thousands of light-years. Gas clouds drawn inward fuel bursts of star formation, while the radiation emitted regulates the dynamics of surrounding material. In galactic mergers, These central black holes eventually collide, releasing gravitational waves that ripple across the universe. In this way, the supermassive black hole is both destroyer and creator, a force of annihilation whose presence simultaneously enables the birth and shaping of stars and planetary systems. It is a paradox. The more dangerous and consuming, the more central to the galaxy's ongoing evolution. Visualizing the environment near a supermassive black hole is cinematic in its drama. Stars race along elliptical orbits, glowing gas forms spiraling patterns of incandescent color, and relativistic jets pierce the void like cosmic lances. Shadows and light twist in ways that challenge perception, as gravitational lensing distorts the view of surrounding objects. The sheer intensity of motion, energy, and gravitational influence creates a sense of awe and existential reflection. You understand that the galaxy is not uniform. Its core is a realm of extremes where ordinary scales of mass, energy, and time are meaningless, replaced by phenomena that stretch comprehension to its limits. Black holes also highlight the theme of contrast that permeates the galaxy. The surrounding regions may be bright with star formation, while the black hole itself is invisible, a void in the midst of activity. Light is consumed even as energy is expelled through jets. Matter is destroyed even as new structures are influenced and created by its presence. This juxtaposition of absence and effect, destruction and creation, darkness and illumination, mirrors the larger narrative of the cosmos. Extremes coexist and balance is found not in stasis but in dynamic interaction. Observing these contrasts evokes both fear and fascination, a recognition that the universe's most powerful objects are also its most enigmatic. The environment around supermassive black holes is also a laboratory for understanding fundamental physics. Extreme gravity allows the study of spacetime curvature, relativistic jets provide insight into particle acceleration, and accretion processes reveal the limits of thermodynamics. Observations of these regions challenge existing theories and force scientists to expand models of physics to accommodate phenomena beyond ordinary experience. For a human observer, this is not merely a scientific exercise but a philosophical one. The black hole represents both the limits of understanding and the promise of discovery. It is a place where the universe tests imagination, knowledge, and perception simultaneously. Emotionally, the experience of observing a supermassive black hole is overwhelming. There is beauty in the swirling accretion disks, terror in the crushing gravity, and awe in the energy unleashed through jets and radiation. It is a realm where ordinary intuition fails, where human perception is humbled by scale, power, and mystery. You feel both insignificant and privileged. Insignificant in the face of such immense forces, privileged to witness even indirectly the processes that shape entire galaxies. The black hole becomes a symbol of extremes, a reminder that the cosmos operates on scales and intensities far beyond ordinary comprehension. The black hole also serves as a philosophical mirror. Its consuming gravity, invisibility, and transformative power evoke reflections on human existence, mortality, and the limits of knowledge. Just as light cannot escape its grasp, so too do some truths about the universe remain hidden, accessible only through careful observation, inference, and imagination. The black hole embodies paradox. It is nothing and everything, destructive and generative, silent yet influential. Contemplating it evokes both fear and inspiration, a visceral understanding of the universe's complexity and power. Even as you move away from the galactic core, the presence of the supermassive black hole lingers in thought. Its influence extends far beyond its event horizon, shaping the galaxy's structure, energy distribution, and evolution. It serves as a reminder that the galaxy is not merely a collection of stars and planets, but a dynamic system where gravity, energy, and matter interact in profound and often invisible ways. The black hole is the ultimate anchor of this system, a force of extremes that commands both attention and respect. By the time you leave this region behind, the impression of the black hole remains indelible. It is both terrifying and majestic, a cosmic powerhouse that exemplifies the interplay of destruction and creation, darkness and light, stillness and motion. Its presence underscores the galaxy's complexity, illustrating that the most significant forces are often invisible yet central to the universe's ongoing narrative. In contemplating the black hole at the core, you gain a deeper understanding of the cosmos, a realm of extremes, contrasts, and hidden forces that define both structure and evolution, inspiring awe, curiosity, and philosophical reflection in equal measure. Venturing outward from the galactic core, your gaze encounters dazzling concentrations of stars known as star clusters, compact islands of light scattered across the vast darkness of space. These clusters vary widely in size, age, and density, from tightly packed globular clusters containing hundreds of thousands of ancient stars to sprawling open clusters with only a few dozen young, brilliant stars. The first impression is one of wonder. Entire systems of suns, each burning with its own energy and history, congregated in astonishing proximity. Their collective light forms bright, shimmering beacons against the dark backdrop of the galaxy, punctuating the void with a sense of order amidst chaos. Observing them evokes both visual awe and a profound realization of the diversity and complexity of stellar evolution. Globular clusters are particularly mesmerizing. These ancient stellar cities, often more than 12 billion years old, represent some of the galaxy's earliest formations. Stars within these clusters orbit in intricate gravitational dances, forming dense cores where distances between stars are often just fractions of a light year. Their age imparts a distinctive character. Many are red giants having exhausted their core hydrogen, glowing in warm, golden hues that contrast sharply with the blue-white light of younger stars elsewhere in the galaxy. Some clusters harbor exotic remnants, including neutron stars and pulsars, silent witnesses to long-ago stellar deaths. The contrast between their age and the galaxy's ongoing youthfulness evokes both nostalgia and awe, a reminder that the cosmos is a continuum of life cycles stretching across eons. Open clusters offer a different, more ephemeral spectacle. These young stellar gatherings are often embedded within the gas and dust of their birth nebulae, their brilliant blue and white stars illuminating surrounding material. They are dynamic and less gravitationally bound than globular clusters, with stars slowly drifting apart over tens or hundreds of millions of years. Observing an open cluster is like witnessing a cosmic nursery. Stars ignite, shine brightly for a fleeting period, and eventually scatter, leaving only subtle traces of their birth. The visual contrasts are striking: hot, luminous stars piercing through hazy clouds of dust, casting long shadows and sculpting surrounding material into intricate shapes. These regions are alive with energy, a testament to the ongoing process of creation that defines the galaxy. The spatial arrangements within star clusters are fascinating. Gravity ensures that stars orbit a common center of mass, creating dense cores surrounded by more loosely bound outer regions. The interactions within clusters are complex. Stars may exchange partners, gravitationally slingshot each other into new trajectories, or even collide in rare, violent events. These interactions are slow on human timescales but inexorable on cosmic scales, gradually reshaping the structure of the cluster over millions of years. The dynamism within these seemingly static points of light is profound, revealing that even in tightly knit communities, motion and evolution never cease. Emotionally, star clusters evoke a mixture of serenity and exhilaration. The dense, orderly arrangement of stars and globular clusters conveys stability and endurance, a testament to the persistence of matter over billions of years. In contrast, the ephemeral nature of open clusters evokes a sense of fleeting beauty, the brilliance of youth destined to scatter and fade. These emotional contrasts mirror the physical contrasts within the galaxy: permanence and impermanence, stability and change, tranquility and chaos. Observing clusters in this context encourages reflection on both the scale of the cosmos and the passage of time, reminding you of the transient yet recurring nature of creation in the universe. Star clusters also act as laboratories for understanding stellar evolution. Their stars share similar ages and compositions, allowing astronomers to study the processes of nuclear fusion, energy transport, and stellar death in comparative detail. By observing clusters, patterns emerge: the progression from main-sequence stars to red giants, the appearance of white dwarfs, and the formation of exotic remnants like neutron stars and black holes. Clusters reveal the life stories of stars on a grand scale, compressing billions of years into observable structures that illustrate the rhythms of cosmic evolution. For a curious observer, these clusters are both visually stunning and intellectually rewarding, offering a dual feast of beauty and knowledge. The interplay of light and shadow within clusters creates dramatic visual effects. Stars near the core may appear densely packed, their combined light forming luminous halos, while the outskirts are more sparse, revealing the darkness of interstellar space beyond. In open clusters, young stars illuminate surrounding dust, casting subtle shadows and creating intricate patterns of brightness and color. The contrasts of density, age, and luminosity within clusters provide a natural tension, enhancing visual engagement and giving the galaxy a textured, layered appearance. Observing these variations evokes a sense of depth and dimensionality, as if the galaxy is a three-dimensional painting, each cluster a brushstroke of light. Interactions between clusters and their environment are equally compelling. Stellar winds from cluster stars push against surrounding gas, creating cavities and filaments. Supernovae inject energy and heavy elements, enriching nearby regions and influencing the formation of future stars. Some clusters orbit the galactic center in elongated paths, their motions tracing gravitational contours that reveal the mass and structure of the galaxy. Others drift through interstellar space, slowly losing stars to tidal forces that pull them away over time. Each cluster is both a product and a participant in the galaxy's ongoing narrative, contributing to the dynamic interplay of matter, energy, and time. The sheer diversity of star clusters is astounding. Some are ancient relics, nearly as old as the galaxy itself, while others are newborn, still wrapped in the clouds of their birth. Some are densely packed, gravitationally robust, and resistant to external forces, while others are fragile, their stars destined to disperse. This variety underscores the complexity of galactic structure and evolution. The galaxy is not uniform, but a mosaic of regions with different histories, compositions, and fates. The contrasts in age, density, and luminosity provide endless visual and intellectual fascination, creating an environment rich in both mystery and discovery. Observing star clusters evokes a sense of interconnectedness. Stars within a cluster may be born together, sharing chemical compositions and histories, yet their futures diverge dramatically. Some will end as red giants, others as supernovae, some as white dwarfs quietly cooling over billions of years. Their evolution influences neighboring regions, seeding space with heavier elements, triggering further star formation, and shaping the interstellar medium. Each cluster is a microcosm of the galaxy itself, a concentrated reflection of the cycles of birth, life, and death that define the cosmos. Finally, as you leave the regions populated by star clusters, the impression they leave is profound. They are islands of light amidst the darkness, each with its own character, history, and story. They embody contrasts: youth and age, density and sparsity, brilliance and shadow. They demonstrate the galaxy's capacity for both stability and change, creating a narrative that stretches across billions of years and countless light-years of space. In contemplating these islands of light, you gain a deeper appreciation of the galaxy's complexity, its beauty, and its perpetual cycle of creation and transformation. Star clusters are not merely collections of stars. They are luminous testimonies to the ongoing drama of the cosmos, eternal yet ever-changing, quiet yet profoundly expressive in the story of the universe. Beyond the ordered structures of stars, clusters, and filaments, there exists a more solitary and enigmatic population: rogue planets. These are worlds untethered to any star, drifting silently through the dark expanses of the galaxy. Unlike planets in stable orbits, they wander alone, carried only by the galaxy's gravitational tides. Their existence challenges conventional understanding of planetary systems, suggesting that formation and survival are more chaotic and unpredictable than once imagined. Some of these planets were likely ejected from their original solar systems during violent gravitational interactions, while others may have formed independently in dense molecular clouds, never acquiring a parent star. The scale of their isolation is staggering. A single rogue planet may traverse light-years of empty space without ever encountering another celestial body. In the cold vacuum between stars, temperatures plummet, leaving these worlds dark and frigid, often with frozen atmospheres and oceans beneath icy crusts. Yet despite this extreme solitude, rogue planets carry potential for mystery and wonder. Some may harbor internal heat from radioactive decay or residual formation energy, possibly allowing subsurface oceans to persist in liquid form. In these hidden pockets, life, or at least prebiotic chemistry, could exist, shielded from the lethal radiation and vacuum of space. The contrast between the stark, frozen surface and the hidden, warm interior evokes a haunting beauty, a sense of worlds living in secret, unseen by the light of stars. Rogue planets also illustrate the galaxy's unpredictability. Their paths are shaped by gravitational encounters with stars, clusters, and even black holes, sending them on trajectories that can span tens of thousands of light-years. Occasionally, one may pass close enough to a star to capture temporary illumination, while more rarely, collisions with other objects can create dramatic impacts, reshaping surfaces or triggering brief luminous events. Observing these solitary travelers evokes both fascination and existential reflection. They are reminders that the galaxy is not solely composed of stable, predictable systems, but also of wanderers, lost and free, each carrying a story of violent birth or exile. Emotionally, rogue planets inspire a sense of awe and melancholy. They are symbols of solitude, resilience, and mystery, drifting endlessly in the darkness, yet their existence underscores the dynamic, ever-changing nature of the galaxy. They are reminders that life in the cosmos can take unexpected forms and that even in the cold void, matter endures, quietly traversing the vast, interconnected web of the universe. These drifters highlight contrast on a profound level: motion versus isolation, darkness versus hidden warmth, chaos versus endurance, reinforcing the galaxy's endless complexity and the boundless imagination required to comprehend it. Rogue planets, silent and unseen for most of cosmic history, thus become a testament to the galaxy's richness. They are the hidden wanderers of space, moving without guidance, yet integral to the grand tapestry of matter and energy. In contemplating their journey, one appreciates both the fragility and resilience of worlds, the unpredictable nature of the cosmos, and the beauty inherent in wandering alone through the infinite darkness. As you continue to traverse the galaxy, your attention is drawn to an intricate and captivating phenomenon: binary star systems. Unlike solitary stars, binaries are pairs locked in a gravitational embrace, orbiting a common center of mass in a delicate cosmic dance. These systems are surprisingly common, making up a significant fraction of all stars in the galaxy, yet each pairing is unique, with differing masses, separations, and orbital rhythms. Observing them is a study in contrast: harmony and tension, attraction and centrifugal force, stability and potential chaos, all expressed through the elegant motion of light years of stellar matter. Binary systems come in many forms. Some are wide binaries, with stars separated by thousands of astronomical units, moving slowly around one another in vast, leisurely arcs. Others are close binaries, where stars orbit so tightly that tidal forces distort their shapes, sometimes even sharing outer envelopes of gas. These interactions can have profound effects on stellar evolution. In some cases, one star will siphon matter from its companion, altering lifespans and triggering exotic phenomena like novae or X-ray emissions. The visual effect of these close interactions is striking: streams of glowing plasma connecting stars, jets of matter ejected into space, and rapid variability in brightness as material exchanges or eclipses occur. The dynamics of binary stars illustrate the balance between cooperation and conflict. Gravity holds them together, yet the exchange of mass and angular momentum introduces tension. Some systems are stable for millions or even billions of years, while others experience dramatic events leading to the destruction or transformation of one or both stars. Supernovae can occur in binaries when a white dwarf accumulates enough matter from its partner, while neutron star or black hole binaries can spiral together, eventually merging and releasing gravitational waves. These cosmic events are violent, yet orchestrated by the precise laws of physics, demonstrating both the predictability and unpredictability inherent in the galaxy. Emotionally, observing binaries is mesmerizing. Their rhythmic orbits convey elegance, their interactions reveal drama, and their consequences illustrate the interplay of time, energy, and matter on a grand scale. There is tension in their closeness, beauty in their motion, and awe in their power to transform the surrounding space. Binary stars encapsulate the galaxy's dualities: cooperation and conflict, stability and change, light and shadow. Their dance is a microcosm of the larger cosmic narrative, where forces interact across distances unimaginable, creating patterns that are at once predictable and surprising. Binary systems also highlight the interconnectedness of cosmic processes. Their gravitational influence can affect surrounding planets, clusters, and nebulae, while interactions such as mass transfer can produce radiation that illuminates distant gas clouds. They serve as laboratories for understanding stellar evolution, matter transfer, and the extremes of physics. In contemplating the intricate dance of binary stars, you gain insight into the elegance and complexity of the galaxy, witnessing firsthand how motion, energy, and gravity intertwine to produce phenomena of staggering beauty and consequence. Binary stars, in their endless orbit, thus become symbols of balance, tension, and cosmic choreography. They are both stable and volatile, solitary yet connected, destructive yet creative. Observing their dance reinforces the understanding that the galaxy is a place of motion, interaction, and contrast, where every system, from solitary drifters to tight binaries, plays a role in the ever-unfolding story of cosmic evolution. As you journey deeper into the galaxy, certain stars capture your attention not through gentle glow, but through rhythmic, almost mechanical flashes of energy, pulsars. These are rapidly spinning neutron stars, the remnants of massive stars that ended their lives in spectacular supernova explosions. Despite their small size, often no more than 20 kilometers in diameter, their density is unfathomable, packing a mass greater than that of our Sun into a sphere the size of a city. Pulsars emit beams of electromagnetic radiation from their magnetic poles, which sweep across space like cosmic lighthouses. To a distant observer, these beams appear as precise pulses, arriving at regular intervals that can rival the accuracy of atomic clocks, a stark contrast to the chaotic vastness of the surrounding galaxy. The birth of a pulsar is violent and transformative. When a massive star exhausts its nuclear fuel, its core collapses under gravity, compressing matter to incredible densities. Electrons and protons merge into neutrons, forming a neutron star with intense magnetic fields a trillion times stronger than Earth's. The collapse causes the star to spin faster, sometimes hundreds of times per second, producing pulsations that are detectable across thousands of light years. Surrounding gas and debris from the supernova are often illuminated by the pulsar's energy, forming glowing nebulae that showcase the ongoing impact of these remnants. The contrast between the violent origins of pulsars and their precise, clockwork emissions highlights the duality of destruction and order in the cosmos. Pulsars are not only visually striking but also scientifically invaluable. Their regular pulses allow astronomers to measure time and space with incredible accuracy. Variations in pulse timing can reveal the presence of orbiting companions, nearby black holes, or gravitational waves propagating through the galaxy. Some pulsars rotate so rapidly and consistently that they serve as galactic navigational beacons, guiding theoretical spacecraft or mapping the structure of the Milky Way. They are extreme laboratories of physics, demonstrating the behavior of matter and energy under conditions impossible to replicate on Earth. Observing them evokes both wonder and intellectual curiosity, as they embody the extremes of density, magnetism, and rotational speed in the universe. Emotionally, pulsars evoke a mixture of awe and reverence. Their pulses are relentless, unfaltering, and eternal in human terms, a stark reminder of the precision inherent in nature even amid cosmic chaos. Each flash is a heartbeat of the galaxy, a signal of life after death, a manifestation of energy enduring long after the star that birthed it has collapsed. There is poetry in their rhythm, a silent yet observable proof that order emerges from catastrophic endings, that even in destruction, the universe can create mechanisms of extraordinary consistency and beauty. Pulsars also illuminate the interconnectedness of galactic phenomena. Their emissions can energize surrounding nebulae, influence the dynamics of nearby gas clouds, and even affect the formation of future stars. They are not isolated curiosities but active participants in the galaxy's ongoing evolution, linking past supernovae to future stellar birth. Observing pulsars reinforces the sense that the galaxy is a dynamic, interconnected system where even the smallest, densest objects can exert profound influence over enormous scales. In their ceaseless rotation and precise emission, pulsars become cosmic metronomes, measuring time, space, and the forces that shape the universe. They are both survivors and markers of cosmic history, embodying contrasts of chaos and order, death and endurance, fragility and power. Watching a pulsar pulse across the void is to witness the galaxy's rhythm made manifest, a brilliant, steadfast signal that the cosmos, in all its vastness and violence, can also produce astonishing precision, harmony, and enduring wonder. As you traverse the galaxy, the calm grandeur of stars and nebulae is occasionally interrupted by violent, awe-inspiring events, cosmic collisions. These are moments when massive bodies, be they stars, clusters, or entire galaxies, interact with such force that they reshape their surroundings, releasing energy on scales that defy ordinary comprehension. Collisions are both destructive and creative, tearing apart old structures while triggering the birth of new ones. Observing them evokes a sense of drama and urgency, a reminder that the galaxy is not a static panorama but a living, ever-changing entity, where matter and energy engage in constant, spectacular interplay. Galactic collisions are among the most striking. When two galaxies approach, their mutual gravity stretches and distorts their forms, pulling stars and gas into elongated tidal tails that extend for hundreds of thousands of light years. Star formation often ignites in the resulting compressed gas clouds, producing brilliant clusters that shine like jewels across the darkness. Despite the apparent chaos, these interactions are orchestrated by the precise laws of physics, creating intricate patterns that merge destruction and creation in ways that are both violent and visually breathtaking. The contrast between the vast emptiness of space and the explosive energy of colliding systems highlights the duality inherent in the cosmos. Immense calm punctuated by bursts of transformation. Closer encounters, such as stellar collisions, are equally dramatic on a smaller scale. In dense star clusters, interactions can fling stars into new orbits or, in rare cases, cause direct impacts. The resulting explosions or mergers release tremendous energy, sometimes forming exotic objects like neutron stars or black holes. Gas and dust are compressed, often triggering further rounds of star formation in the surrounding region. These events illustrate the cyclical nature of cosmic evolution. Endings become beginnings, destruction begets creation, and chaos is tempered by the structure imposed by gravity and momentum. Even planetary systems are not immune. Stars passing near one another can disrupt orbital stability, sending planets careening into new trajectories, ejecting them from their systems entirely, or causing catastrophic collisions. Rogue planets may be born from such encounters, drifting alone through interstellar space as a testament to the galaxy's unpredictability. The scale of these interactions emphasizes both fragility and resilience, revealing how delicate balances govern the lives of worlds and stars, yet also how matter persists, adapts, and continues to evolve despite upheaval. Emotionally, cosmic collisions evoke both fear and fascination. They are violent, unpredictable, and powerful, yet they are also agents of creation, producing new stars, structures, and phenomena. Witnessing a collision is a lesson in impermanence and transformation. Nothing in the galaxy is fixed, and even the most massive, seemingly eternal objects are subject to change. The contrast between destruction and creation, chaos and order, energy and emptiness underscores the dynamic, ever-shifting nature of the cosmos. Cosmic collisions remind us that the galaxy is alive, in motion, and interconnected. Every interaction, from the smallest stellar encounter to the merger of entire galaxies, ripples through space, influencing the formation, movement, and evolution of countless other systems. Observing these events is both humbling and inspiring, a vivid demonstration that the universe is not merely a backdrop for stars, but a stage for continuous, dramatic storytelling written across the vast reaches of time and space. The galaxy is in constant motion, and collisions are its most spectacular punctuation marks, signaling both endings and new beginnings, chaos and opportunity, darkness and illumination. CCCC.